everyone, in this video we will talk about a systematic step-by-step approach to data handling and data science and a proper approach to all the types of machine learning. So let us just start quickly. So by the end of this video you will be able to classify machine learning into supervised, unsupervised and reinforcement learning, have an overview knowledge of each type of these, have a systematic idea leading to the deploy of AI model, and know the meanings of overfitting and underfitting in machine learning study. So how to approach a given set of data? If you remember, this is the same table which I had shown in my first video of introduction to machine learning. So what let me just quickly recall it. You see here height and weight are given, so these are somehow maybe related. I am not telling that height and weight will always be related by some y equals to fx function, but there may be two sets of data. Just for an example, I am telling this, which may be related somehow. Now what will the machine do? It will find the logic and it will find an approximate function y equals to fx, and it will try to predict what will be the weight of a person who is having 6.1 height. Okay, so what do we do exactly for this kind of problem? Suppose there are lots of data, so we have lots of coordinates x comma y x comma y. So what we do, we first plot them. We are plotting it in a curve xy axis. So now we try to find the best line fit. Now you can see this may be the best line fit. Now I will tell you how to find this line fit, what is the mathematics behind this, how to apply this in Python in my later videos. But for now you just understand that for proper data handling you have to plot the points, right? X comma y points, and then you have to find the best. It may be a line, it may be a polynomial curve, second degree, 2 degree, anything. So how do we approach? So first we have to get the data. So from the source we have to get the data, then we have to analyze the data. We will see today how to analyze the data and also clean the data. We will see each of these meanings today, that how to clean the data, how to analyze the data, filter the data which are not required, excess data, training the data, testing the data, and deploying model. What is meant by this training and testing? Suppose I have 100 of the columns, 100 of rows in 2 columns, suppose. And then what will I do? I will just say that 80% of my rows will be for training purpose. I'm training the model, means I'm plotting and training the model to find the best line fit. And then some in some future x whose data I don't have, I will use those as testing. Testing means I will feed the x and see whether it is coming near to my line. Right. This is the line means the predicted value, and these are the actual values, the points. So that way we train the data first and then we test the data whether our model is actually working or not, and then we deploy our AI model. So let's say you build an AI model which has successfully found the relation between height and weight and some other factors, maybe some other medical factors. So if you feed the AI model about the height of a person, the AI will tell what is the expected weight of the person, and this can be very accurate, up to 80 to 90% accuracy. So this is the fun part. Now there can be types of machine learning are supervised, unsupervised, and reinforcement learning. So we'll see each of these. Supervised learning, when we have the sample input as well as the output, then it is known as supervised learning. Previous example was of supervised learning. The example of height comma weight, we have the value of height in our training data. We have the value of height. We also have the value of weight. Both values are provided to us. Then we are asked to find out the weight of some unknown height, right? So when both the input as well as the output are given, it is known as supervised learning. It has two subcategories: regression, when the output is a continuous number, when there is an approximate functional relationship between the input and the output. Yeah. So what I showed you was actually linear regression. It was a linear curve. So price prediction of a house, you can say it like you tell the acres of area, you tell the facilities of the housing, and suppose there is a third column which says the price of prediction of the house. So this is also a type of regression. Life and lifespan prediction, suppose if you provide the data of your daily activities, what you do the most, I can also predict your lifespan. The machine learning model will be able to do so. Then the regression is like this. And the classification, what does it mean? When the output is finite or discrete values and can be categorized into classes, predicting flower species, predicting whether someone died in Titanic or not. So see this classification, what does it mean? The previous slide we saw about regression, that linear regression one. So what does classification means? If I provide you the characteristic of a flower, for example, in the iris data set, I had provided you about the petal length, petal width, and sepal length, sepal width. So I am providing you the characteristic of a flower, and I am uh, telling you to tell me which species does the flower belong to. So our our output is categorized in some classes. We cannot tell the species of elephant or something like this. But see, in linear regression, what happens, like the height and weight, I told you, any height you give, there will be a large category of weight. The weight can be anything, right? The line can extend up to infinity, and you can ask some other heighted very मतलब height person who has a greater height will have greater weight, assuming something like that. So this is not like that. You are not predicting any numerical value, you are predicting what is the species of the flower. So this type of machine learning functions is known as classification. So now we'll see about unsupervised learning. Here we don't have the output but only have the input values. We only have the input values, like we only are having the height. So how to predict the weight? You cannot predict the weight in that way. Maximum what you can do, you can cluster them into short heighted, medium heighted, large heighted. So unsupervised learning can be done by finding clusters. For example, you give me fruits, I will cluster them into citrus or gourd fruits, right? K means clustering is one name of an algorithm. Anomaly detection, this is for detecting suspicious credit card transaction. For example, a person who has been means drawing some money from his account, like is you can using machine learning you can means track the daily transactions, right? So from suppose for 10 years a person is only transaction is somewhat of it is plotted in a graph. It is then what you do, then suppose there is some scam happened with the person. So you will suddenly see a very anomalous behavior in the graph of that transaction. So you can detect the suspicious credit card transactions in this way using an AI model. Now let us see the reinforcement learning. It performs an action A and gets a reward B, and hence it tends to take action that maximize rewards. This is the thing which we'll talk about later. Example, minimax algorithm, it is mainly used for making games. So what it does, it performs an action A. The algorithm will perform certain actions and it will get a reward may be in the terms of number. Like if you do some good action, you will get a reward of 1. If you do some unfavorable action, you will get a reward of 0. So suppose I design an algorithm with which is maximizing the rewards, so it will always take the actions leading to better rewards. So how can this be useful in making games? We will see that some later time after we complete machine learning and then all this is a very different part of machine learning, so we'll later see this. Now the data validation part is really important. A yet new data set to test the hypothesis in case the algorithm got overfitted even to the test data due to multiple attempts of training. It is important to keep the algorithms generic so that it can handle generalization for future data. So you see, let us see what is underfitting, just right, and overfitting. Now see, an AI model will have certain accuracy, right? I told you 80 to 90% accuracy, but why not 100%? So it depends on the AI model. We generally don't want 100% accuracy. Let's see why we don't want 100%. Let's see, this is underfitting model, you can easily see that this is not correct. This is just right. Now, if we want 100% accuracy, we may draw a line which is very curved and covering all the points. It is passing through all the points, right? It is covering, but this is overfitting. We are getting a lot of accuracy. We are getting 100%, but we can't tell what is the polynomial. Like this, if we extend this curve towards the left and right, so we can say that at some other time what will be the value, right? We can be near the value at least, but here we cannot be near the value also, because we don't know how this zigzag pattern will go after this, whether it will be equidistant zigzag or some other zigzag. We know nothing about this. We are getting initially 100% accuracy, but when some other data will be given to us, we will be trapped. Now we are enjoying the 100% accuracy, but new data we cannot do that. So this type of stuff is known as overfitting. This is very important. We have to take care this does not happen with our machine learning model while coding. The explanation of overfittings, to see this, I have created a graph. Right, this line is definitely underfitting these plot data values. So I draw a curve which is the exact correct one, and you see now few points like this and this does not fit in. So suppose I want 100% accuracy and I draw some polynomial curve like this. You see my cursor? Suppose I draw some polynomial like this, some higher degree polynomial I am drawing, right? And I draw the higher degree polynomial in such a way that like it covers all of my points. So now we are enjoying 100% accuracy, but when someone will tell us what, suppose we went through this to cover this point, we are taking a turn like this, so we are missing this data value. So someone, suppose for some x we need to find the y, our y output will be there because we have taken a turn to cover this 100. So overfitting, basically you understand the concept now, right? Overfitting, we are, if the model is overfitted, then we are enjoying initial 100% accuracy, but it is not desirable always. So we see when there is a low variance, I told this in the mathematics portion also, there will be high bias, simple model, underfitting, and there is a high variance, there will be low bias, complex model, overfitting. Bias versus variance trade-off, I told how will be the graph of this look, how will the graph of this look like in my maths class. So yeah, that's all from this video.